Today's joinery symposium is not just about making joints, but will give you an overview starting with the tree itself through the glued up project. We'll cover wood movement, grain selection, milling, how to choose and make many of the different common joints, as well as gluing and clamping strategies. The goal is to broaden your overall knowledge so that you can incorporate some of those ideas into your shop. It doesn't matter if you build using dowels, pocket screws, or mortise and tenons. So don't let the joinery snobs dictate that you have to use dovetails for drawer boxes, because you don't. It's definitely been a group effort from our members, all of which will be mentioned during the day. So let's get started. Any presentation about joinery has to start with an understanding of wood movement and grain direction. So let's spend a few minutes on these two very important subjects. Let's start from the beginning. As a tree grows and bears weight in response to gravity and prevailing winds, the tree creates new growth to compensate for those forces, resulting in compression and tension grain inside the trunk and branches, as well as changes in grain direction and width. These natural internal tensions within the complex cellular lattice work of a tree are very difficult to anticipate. In addition, when a hardwood tree is cut and sawn into lumber, half of its weight is water. It's then put in a kiln and dried to about 8 to 10% moisture content. Because of these natural stresses combined with kiln drying, it's no wonder you see these kinds of boards, although exaggerated, at the lumber yard. And when you mill a board in your shop, it may change shape within minutes or even immediately as it releases those internal pent-up stresses. But wood movement does have some hard and fast rules. For example, wood expands in the summer with higher humidity and contracts in winter with lower humidity. I think most everyone can understand these environmental causes of wood movement. This absorbing or releasing of moisture, while minimal in a home with HVAC, will continue as the wood cells try to reach EMC, or equilibrium moisture content, with the surrounding air. But how does wood actually expand and contract? Well, wood expands and contracts the most tangentially, or along the same direction as the growth rings. Wood moves about half that amount radially, or across the rings. But wood moves very little along the length of a board. To put it simply, a plain sawn board, one in which you see cathedrals, with the grain running vertically, expands and contracts the most in its width. The amount of movement is minimal, and you don't have to really worry about it for boards under 4 inches wide. But if you have a solid wood panel that is 18 inches wide, you will get enough wood movement to open up joints or even crack the panel if your joinery doesn't address the wood movement. It's these complex relationships between internal tensions and environment that explains the reasons why boards do crazy things like cupping, bowing, twisting, and crooks when you try to use them for joinery. I find that when I do a project with new lumber, I stack it for quite some time to equalize moisture within my shop's environment, which is heated and cooled, so the humidity stays relatively constant. This may last for a week to several months for thicker stock. Then when I start the project, I mill to a larger rough dimension, usually 1/8 to 1/4 inch for width and thickness, and 1/2 inch or more for length, and store it in my shop with wooden stickers between them. In this way, I know it has reached EMC in my shop. Then as I work on individual components, I mill them to final dimension, do the joinery, and assemble them within a day or at most a few days. This minimizes many of the problems discussed so far. At the lumber yard, I usually buy rough sawn lumber, which can be difficult to read the grain from by looking at it. And the ends are usually painted or sealed. So why would I buy rough sawn lumber when grain is so important? Well, the reason is that rough sawn lumber gives me more options in determining the final thickness of my parts and more material to work with during milling. It also gives me all the wood that I paid for. Plus, buying rough lumber can be a little cheaper in some cases. If you have access to quality lumber with minimal warping, I recommend buying a full 1/4 inch over your planned finish dimension under 2 inches. Buy 2/4 or a 1/2 inch above your finished dimension if it's 2 inches or more. It's important to understand that it doesn't really matter what the finished thickness of your boards are, as long as all the boards of the same type are the same thickness. An example would be you want the final thickness of all your aprons of your table to be around 3/4 of an inch. If I buy 4/4 rough lumber, it's usually right at 1 inch to 1 1/8 inches. And I'll mill it down to maybe 7/8 or 15/16 depending on the defects that I see in the wood. It might end up being only 13/16, but it doesn't have to be exactly 3/4 inch, as long as all the aprons are the same thickness. I've even had cases where I had to go below 3/4 in order to remove all the defects and get all my parts to the same thickness. So at my shop, before deciding which boards to use for individual components, sometimes I'll cut off the painted ends, which not only removes some checking, but also allows me to find out a lot about the board. Here you see 2 ends from a 9-foot 1/4 sawn white oak board that I recently purchased from Peach State Lumber, one of the Guild's patron sponsors. You'll notice that the grain is in fact 1/4 sawn and is consistent from one end to the other. That's a good sign that the board will not do wonky things when I mill it. However, that's not always a guarantee. You'll also notice on the right edge that the corner is getting close to the pith of the tree, or the center. Since wood warps typically occur away from the pith or towards the bark, this board should have a bow to the outside, and sure enough, it does. So now I know that this board, except for the one edge nearest the pith, will work well, since straight grain is a requirement for my particular project. This ends technique can remove the need to joint and plane to find this information out, although skip planing is another technique that I'll explain later on. Checking the ends easily allows me to inventory 1/4, rift, and plane sawn quantities, and to figure out which boards I will use for different parts. Board ends that are poorly matched indicates warping will occur during milling, and that maybe I should use that board for shorter pieces or where continuous grain is not required. I mentioned 1/4 sawn, rift sawn, and plane sawn, also known as flat sawn. Here's a handy diagram for reference showing the differences between these different cuts. Suffice to say that 1/4 sawn moves very little and is great if you want straight grain or if you want to see ray fleck in certain woods. Rift sawn is considered by many to be the best wood to work with, as wood movement is minimal. And it has nice straight grain on all 4 sides, making it ideal for table legs and furniture legs. Plane sawn is what you will see mostly at the lumber yard, because that is the fastest and cheapest way for a mill to get the greatest yield from logs. Look for the cathedrals on the surface of the board and you'll know that it is plane sawn, as you see on the left. Plane sawn boards very often have rift and 1/4 sawn wood as you get further away from the pith and closer to the edges. Once you have your lumber and it's acclimated to your shop, it's time to do the rough milling. If you buy lumber that is already surfaced, you still have to do some milling because S3S and S4S lumber surfaced on 3 or 4 sides will still have some of the warping issues that we discussed, but you'll have less thickness available to solve those issues during milling. In most shops that are machine oriented, I apologize to you hand tool only woodworkers, the combination of a jointer, planer, and a table saw are typically used. The jointer helps you flatten one face of a workpiece and then square one edge adjacent to that face. The first steps in turning rough lumber into furniture quality stock. Follow up jointing with a thickness planer to make the board a consistent thickness, and a table saw to rip the remaining edge parallel, and you create squared up stock. Squared up stock is an absolute requirement for good joinery. Before we start milling, let me give you a few tips about setting up your jointer. While this is not a comprehensive guide, these are the main things that I check on a regular basis. First of all, I take a straight edge and place it over one of my cutters. If you have a 3-bladed jointer, put the straight edge over one of your knives. Then with the jointer unplugged, rotate the cutter head and the cutter should just kiss the straight edge like this. Be sure to check both ends of the cutter head. Consult your owner's manual for instructions on how to adjust your outfeed table if needed. Then adjust your fence so that you cannot see any light when a 90-degree triangle or square is held up to it. My fence is dead 90 degrees. But it's interesting to note that there is a slight dip in the fence near the top, although the top is touching. That's good enough for me. Also, coating the table and fence with paste wax allows boards to glide more easily. A quick note about feed direction. If you have a jointer or planer with a traditional 2 or 3 knife system, you'll have to pay attention to feed direction. Otherwise, you'll get a lot of tear out if you feed in the wrong direction. A number of years ago, I chose to buy or upgrade my jointer and planer with helical cutter heads, sometimes called spiral cutter heads. This was some of the best money I've ever spent in my shop. Both machines run much quieter and I do not have to worry about feed direction or tear out, and gives me a lot of flexibility to run my boards in either direction when jointing and planing. If I have extremely complex grain, I just run the board through a bit slower or take a lighter cut. The helical blades last a long time, and all you have to do is rotate them as they have 4 cutting surfaces. No more sharpening and reinstalling knives. Yay! Once your jointer is set up and you have your first board in hand, you'll realize one of these types of warp will be predominant. Each board will tell its story when you look down the board, which will tell you the best way to mill it properly. If you have a board with multiple issues, or if one of them is extreme, just don't buy it in the first place. Or if you did buy it, use it only for small projects. If the board face is cupped and or bowed from end to end, place the concave side down to keep the outside edges or ends in contact with the table. Turn on the jointer and using push pads, never your hands, apply light downward pressure against the infeed table as the leading edge of your stock crosses the cutter head. Transfer downward pressure to the outfeed table immediately after passing the cutter head. This is important since the outfeed table is level with the cutter head, so the outfeed table becomes the reference face that you're jointing to. A couple of points need to be made about how hard to push down. A lighter touch is preferred versus pressing down with a lot of your body weight. You can feel the board better with a lighter touch, and pressing too hard can actually take more wood off where you are pressing, especially on the leading edge where you press down hard to start the cut. If you find the leading edge of your board is getting caught on the edge of the outfeed table, but your jointer is set up properly, you're probably pressing down too hard. Lighten up and get more of a running start with your board and push it through to the outfeed table. I think what happens is the leading edge of the board develops a tiny bit of tear out as it passes over the cutter head, and that catches on the outfeed table. If you press down too hard on one side of the board than the other, your boards may come out looking like a trapezoid. If you ever notice that, you're probably pressing either unevenly or too hard. I know because I've done this. The aforementioned paste wax is an easy solution if you are guilty of this. If you are pressing unevenly, just be aware of it and you'll stop it. Also take care not to press a bowed board flat to the infeed table, as it will only spring back after completing the cut. Using a push stick that hooks over the end of the board helps with this. To know when you've completely flattened a face, run a squiggly pencil mark on its surface and make passes until the pencil mark disappears. For boards longer than the infeed table and bowed end to end, cross-cut them into shorter parts if possible. In cases where you cannot, you can put it bow down and just take passes near the ends until it meets near the middle. Then run the entire board through as normal, referencing off the outfeed table. The same applies when running a board with a crook along the edge. A rule of thumb is that you need a jointer bed that is at least 1/2 the length of your normal board. If you consistently do boards longer than that, you will need additional infeed and outfeed support like this, or a longer jointer. To joint an edge square to its now flat face, place the freshly jointed face firmly against the fence. Use the same downward pressure technique as you did when jointing the face. Make sure you use a push pad to push the board against the fence, preferably a point just past the cutter head. Fences flex, and this assures consistency if you push in the same area. Make enough passes to remove a pencil line marked on that edge. Twisted stock requires a unique approach. First, determine the two opposite corners that are touching the infeed table. Put your push pads on those 2 points and push it through the cutter head. This technique prevents the piece from rocking. With each pass, you create more flat surface along each corner, creating a more stable platform to finish the flattening. There's a few special situations I'd like to go over. The first is using offset jointing to assure that tabletops will glue up dead flat, insofar as the joinery is concerned. Lay out your boards and bring 2 adjoining boards together like closing a book. Then joint the edges separately as they are held together. This negates any variance of your fence not being precisely at 90 degrees. Another scenario is jointing boards that are too wide for your jointer. By taking off the guard and using the full width of your cutter head, you can then attach a spoil board to the same side where it was flattened, and then planing the other side. You can then flip the board over after removing the spoil board and plane the remainder of the original side. I had to say I do not like the CA glue and blue tape trick. I tried it and glued the boards together because it's too hard to line up the tapes. A final technique I have used is skip planing. This involves taking light passes with a jointer or planer in order to see the grain. If you like, it can even be used to create a rustic look. After jointing, you not only want to flatten the opposite side of the board, but you also want it parallel to the first side. You can't do that with a jointer, but you can with a planer. That's because your just flattened side that you did on the jointer references down on the bed of the planer. Since the planer's cutting head is above the board, the result will be a parallel side. Snipe can be a problem. This is where you get a small dip in the surface near the beginning or end of a board as soon as one of the 2 internal feed rollers release. When it does happen, I simply raise up on the board when it enters or exits the cutter head. Some planers can be adjusted to minimize or eliminate snipe. Planers are much easier to operate than a jointer because you run boards through it with one face already flattened. I have a DeWalt lunchbox planer that I've used for many years. I added a Helix head a number of years back that cost almost as much as the planer. But it's well worth it. It's much quieter and I don't have to worry about the grain direction at all. Another great add-on to any lunchbox type planer is a Wixie digital gauge. It allows you to make repeatable cuts down to 1/1000th of an inch. It's invaluable when you are trying to get all your boards down to the same thickness, as I am here. Just measure the thickness of each board and write it on the board. Then send the boards through starting with the thickest one and continue to run them all through as you get down to your rough or final thickness. Finally, you can run your boards through the table saw to get your rough or final dimension. And that completes the milling process.